In my previous videos, we have discussed what is DTFT, the definition of DTFT, and the definition of inverse DTFT, as well as we have proved some properties of DTFT. So, by knowing all those, we'll be solving some problems under DTFT. Now, the first problem is x of n is alpha power n u of n, where alpha is less than 1. Now, this alpha is less than 1, that means alpha, let me take a value of alpha to be equal to half. So, if I plot this, my waveform will start from 0 and it will extend till infinity. That is the basic funda which you should be knowing because of the presence of u of n, because u of n starts from 0 and it will extend till infinity. So, my x of n is when alpha is taken to be half, so it is half power 0, u of 0, it is half, 1. Then at 1 you get half, then 1 by 4, 1 by 8 and so on, because you will get half power 1, half power 2, half power 3. So this is the specific example of alpha which I have taken as half. Now in general, the definition from the definition of DTFT, x of e power j omega, the DTFT of x of n is given by summation n is equal to minus infinity to infinity x of n e power minus j omega n. Now what is x of n? It is alpha power n u of n. Now we know that u of n starts from 0 to infinity, or as a whole x of n starts from 0 and it will extend till infinity. So the summation would be summation n is equal to 0 to infinity, x of n is alpha power n, u of n value is what? How does u of n look like? This is the fundamental. U of n starts from n is equal to 0 and continues till infinity. So 0, 1, 2, 3, 4, 5. This is 1, 2, 3 and so on. So u of n value is 1 and you get e power minus j omega n. So summation n is equal to 0 to infinity alpha e power minus j omega power n. Now what is this summation is equal to? Summation n is equal to 0 to infinity alpha power n is, it is sum till infinity of a GP. It is 1 by 1 minus alpha, where alpha in this case is alpha into e power minus j omega. So I will be getting 1 by 1 minus alpha e power minus j omega. So this is the DTFT of x of n is equal to alpha power n u of n when alpha is less than 1. So the DTFT is 1 by 1 minus alpha e power minus j omega where alpha is less than 1. Now if you want to plot this, let me take a typical example of alpha to be positive, that is alpha between 0 to 1. Let me take alpha to be precisely equal to half. So if I plot the magnitude plot, not magnitude, I will directly plot x of e power j omega. It is, we already know that I have proved it in the very first video that the DTFT of x of n is periodic with period 2 pi. So it is 2 pi is a period. So if it is possible if I plot it, it is enough if I plot it between minus pi to plus pi, and it will continue. So it is periodic with period 2 pi. Minus pi to pi, the entire duration is 2 pi. Now at omega, see, x-axis is omega, whereas in CTFT x-axis was this omega. So in DTFT this is the omega what you have. Now when omega is equal to 0, if I substitute here 1 by 1 minus alpha into e power 0, e power 0 is 1. So I will get 1 by 1 minus alpha, right? I think I've made it clear. So when omega is equal to 0, x of e power j omega is 1 by 1 minus alpha into e power 0, it is 1 by 1 minus alpha. So if I had taken a typical value, I had taken a value of alpha to be equal to half. So it is 1 by 1 minus half. It is 1 by 1 minus Half means 1 minus half is half, and it will, when it comes to the numerator, it will be 2. So this value is 1 by 1 minus alpha is 2. Now if I take the value to be pi, x of e power j omega is 1 by 1 minus alpha into e power minus j pi. So that will be equal to 1 by 1 minus alpha into e power minus j pi is cos pi minus j sin pi. Now what is sin pi? Sin pi is 0, sin 180 is 0, cos pi is minus 1. So I will be getting 1 by 1 plus alpha. Now if I substitute the value of alpha to be equal to half, which I have assumed when alpha is between 0 to 1, so it is 1 by 1 plus half, so it is 1 and half, that is 3 by 2. If I take the reciprocal, it is 2 by 3. Now 2 by 3 is lesser compared to 2, so I will be getting a value somewhere here. Similarly, if I substitute the value to be minus pi, I will be getting the same point here. So this amplitude is 1 by 1 plus alpha. So remember, 1 by 1 minus alpha is greater and 1 by 1 plus alpha is smaller when alpha is between 0 to 1. So I will be getting a waveform it will be a sine waveform, sinusoidal waveform which extends from minus infinity to plus infinity but with the period 2 pi. So this is the case when alpha is between 0 to 1. When alpha is negative, what you get is the reflection, not the reflection is this about y axis. This would be called as reflection about x axis, because since alpha is negative, you get 1 by 1 minus alpha to, when you get 1 by 1 plus alpha, since alpha is negative, you will get more larger value compared to 1 by 1 minus alpha. So you get the same sine wave, only the difference will be in the amplitude. So in this problem, you are given with the x of n is equal to 2 power n u of minus n. Now we have direct DTFT equation, x of e power j omega is equal to summation n is equal to minus infinity to infinity x of n e power minus j omega n. This equation is called analysis equation, so which we have discussed in very first introduction to DTFT. So if you want to know more about it, you refer to my previous videos. Now the given question x of n is having u of minus n. Now what is u of n? U of n is a function which starts from 0 and goes till infinity. Now u of minus n is the reflection of this waveform about y axis. So I will be getting this. That means it extends from minus infinity to 0, whereas u of n extended from 0 to infinity, u of minus n extends from minus infinity to 0. So my lower limit will be minus infinity, n is equal to minus infinity, and upper limit would be 0. And what is x of n in that range? It is 2 power n. Again, what is u of n amplitude? It is 1 throughout. Here also u of minus n amplitude is 1 throughout. These samples, individual samples, will have amplitude of 1. So 2 power n into 1 into e power minus j omega n. Now remember, we have equation for GP as n is equal to 0 to infinity alpha power n as 1 by 1 minus alpha, but we do not have it from minus infinity to 0. But since it is summation, we can interchange the limit of summation. So I can write summation n is equal to 0 to n is equal to minus infinity. It is 2 power n e power minus j omega n. Remember this point, the summation limits can be changed without altering the summation value, whereas in integration, if you change the limit of integration, you will get a negative sign. Now how do I make infinity to minus infinity to be equal to infinity? I will put everywhere, put n is equal to minus n. This is the This is a procedure which will be following extensively if you have a negative infinity or negative term in the upper limit, and I want it to be present as infinity. So n is equal to minus n. When n is equal to 0, minus n will also be, I am replacing n by minus n. So minus n also be equal to 0. That means minus n is equal to 0. So it will be n is equal to 0. N is replaced by minus n. So minus n is equal to minus infinity. So n is equal to infinity. And I will be getting 2 e power minus j omega power n. Right? So I will write it here. Summation n is equal to 0 to minus infinity 2 e power minus j omega power n, because I have clubbed the terms containing power n. Now what is n here? It is written as minus n. So it is minus n. Now this can be written as summation n is equal to 0 to infinity 2 power minus 1 e power j omega power n, because I am multiplying by minus 1. So 2 power minus 1 I get. Now what is this summation? N is equal to 0 to infinity alpha. This is of the form alpha power n, which is 1 by 1 minus alpha. So this will be 1 by 1 minus 2 inverse. 2 inverse is what? Half into e power j omega. So this is the DTFT of 2 power n u of minus n. So the next problem is x of n is equal to 1 by 3 power n u of n minus 3. Now this problem can be solved from the definition by using x of e power j omega equation, as well as by using the properties which we have studied. So there are two methods of solving this problem. So I will try to solve this problem in both the methods. Whichever is comfortable to you, you better go for it. Now we know what is u of n. I have been writing it repeatedly, so please bear with me. 0, 1, 2, 3, 4, 5 and n. So u of n is a unit step function which is having an amplitude of 1 and extends from 0 till infinity. Now what is u of n minus 3? This is shifted version of u of n. So for this we have used the property called shifting. U of n minus 3 means shift u of n by 3 towards right. So for more information, look into my videos of shifting, scaling and reflection on signals. So this waveform will be shifted right by 3. That means the sample at 0 will go to 3. 1, 2, 3. 1. This sample will move 1, 2, 3. So 3, 4, 5, 6, 7 and with the same amplitude of 1. All the samples are having amplitude of 1. Now u of n minus 3 exists between 3 to infinity. So from our basics, e power j omega is equal to n is equal to minus infinity to infinity x of n e power minus j omega n. Now since you have u of n minus 3, it starts from 3 to infinity. My lower limit will be n is equal to 3 to infinity. And what is x of n in that range? It is 1 by 3 power n. What is u of n minus 3? Its amplitude is 1. So e power minus j omega n. Now this can be written as summation n is equal to 3 to infinity 1 by 3 e power minus j omega power n. Now we have standard equation for summation of infinite GP, that is n is equal to 0 to infinity alpha power n alpha power n is 1 by 1 minus alpha. That means look at the limit here, the lower limit has to be 0 and upper limit has to be infinity. In my previous video the lower limit was minus infinity, so I had substituted n is equal to minus n. Now here the lower limit is 3. Now how do I make n is equal to 3 to n is equal to 0? This is the standard procedure we will follow throughout the signals and system course when you have a summation whose lower limit is other than 0 and upper limit is infinity. So what you do is, if you have n is equal to 3, you substitute n, 3 you take it to the other side, what you get is n minus 3. You substitute it as some other variable n. Are you guys clear? So it is n, if n is equal to 3, you write n minus 3 is equal to n, or if n is equal to minus 3, you write n plus 3 is equal to n. So if I substitute n is, so the what will be the lower limit? Since n is replaced by m, this will be m is equal to. Now what is the lower limit? When n is equal to 3, 3 minus 3 is equal to 0. So we have achieved our goal, that is the lower limit has to be 0. Now upper limit is n is equal to infinity. Infinity minus 3, it is you are subtracting 3 from a larger quantity, that is infinity. So it will not make any difference to infinity, it will be infinity only. So what you get is 1 by 3 e power minus j omega power n is what? What is n from here? It is m plus 3. So I can write m plus 3. Now the summation is on m. So 1 by 3 e power minus j omega power 3 is a constant. I can take it out. M is equal, so m is equal to 0 to infinity. I can write this as 1 by 3 e power minus j omega power m into 1 by 3 e power minus j omega power 3. So this is independent of m. This factor is not having m term because its summation is on m. So what I get here is 1 by 3 e power minus j omega power 3 summation m is equal to 0 to infinity 1 by 3 e power minus j omega power m. Now this is of the form n is equal to 0 to infinity alpha power n, where n is replaced by m. So I can directly write. So this will be 1 by 3 power 3 is 1 by 27 e power minus 3j omega. So and this summation is 1 by 1 minus this factor. So it is 1 minus 1 by 3 e power minus j omega. So the answer is e power minus 3j omega divided by 27 into 1 minus 1 by 3 e power minus j omega. This is x of e power j omega by using the fundamental equation of DTFT. So the same problem can be done in other way by using the properties of DTFT. Now the question here is x of n is equal to 1 by 3 power n u of n minus 3. Now we know that we know the shifting property of DTFT. What is it? It is if x of n forms DTFT pair with x of e power j omega, then x of n minus n naught forms DTFT pair with e power minus j omega naught x of e power j omega. That means if you have a shift in the input, there will be exponential multiplication in the output. Now, so for this to happen, there should be a shift. See, you have a shift in u of n, that is n minus 3. So there should be similar shift in the term 1 by 3 power n. So how do I write that? 1 by 3 power n minus 3 u of n minus 3. So this is desirable because if you have a shift here, there should be a similar shift in the other terms as well, which contain n. So if I have to write 1 by 3 power n minus 3, what is the extra term which I have added? 1 by 3 power minus 3. So in order to nullify it, I should be adding 1 by 3 power 3, right? So this is my modified x of n. Now this, if x of n forms DTFT with x of e power j omega, this has to form DTFT pair with e power minus j omega n naught. What is the n naught value? What is the shifted value? It is 3 into x of j omega. What is x of j omega? It is the Fourier transform of 1 by 3 power n u of n. What is the Fourier transform of 1 by 3 power n u of n? It is 1 by 1 minus 1 by 3 e power minus j omega. But you have a factor here 1 by 3 power 3. So it is 1 by 27. So the DTFT is e power minus j omega 3 divided by 27 into 1 by 1 minus 1 by 3 e power minus j omega. Now you may wonder why I've written the term here as 1 by 1 minus 1 by 3 e power minus j omega. So I have solved previously a problem wherein the DTFT of alpha power n u of n I have solved. What is alpha power n u of n DTFT? It is 1 by 1 minus alpha e power minus j omega. So this is a standard DTFT pair which we should be knowing, or if you want you can derive or prove and use it wherever you want. So alpha power n u of n DTFT is 1 by 1 minus alpha e power minus j omega. Similarly, what is x of n here? It is 1 by 3 power n u of n. So in place of alpha you have 1 by 3. So it is 1 by 1 minus 1 by 3 e power minus j omega. Since you have a shifted version, it is x of n minus n naught forms DTFT pair with e power minus j omega n naught into x of e power j omega. What is x of e power j omega? It is the Fourier transform, discrete time Fourier transform of x of n. What is x of n? It is 1 by 3 power n u of n. So you get shifted version, that is e power minus j omega n naught. N naught is what? The shift, what do you have here? It is 3, and into 1 by 3 power 3 you have. So this is the final answer which I will be getting by using the property of DTFT in 2 steps instead of using the definition of DTFT. Now the problem here is x of n is equal to u of n. Now we already know the DTFT of alpha power n u of n. What is it? DTFT of alpha power n u of n is 1 by 1 minus alpha e power minus j omega. So this is a standard equation. Now this is when x of n is equal to alpha power n u of n. This is x of e power j omega. Now in place of alpha I have 1 into u of n. So alpha has to be 1. So it is of the form 1 power n u of n. So 1 power n is what? Always n. So it can be written as DTFT in alpha is 1, so 1 by 1 minus e power minus j omega. So this is the DTFT of u of n. This is also a standard equation. It is 1 by 1 minus e power minus j omega. Now the fifth problem is x of n is equal to delta of n. Now if you want to find DTFT, we will go from the basics. X of e power j omega is equal to summation n is equal to minus infinity to infinity x of n e power minus j omega n. That is equal to summation n is equal to minus infinity to infinity. X of n is delta of n e power minus j omega n. Now this delta of n is defined, we know from basics that delta of n is having an amplitude of 1 at n is equal to 0. So it is defined only at n is equal to 0, not for any other values. So the summation will be equal to e power minus j omega n at n is equal to 0. So it will be e power 0 and it is 1. So x of e power j omega, that is DTFT of delta of n is 1. That means for all the values of omega the amplitude is 1 and phase will be 0 because it is not having any imaginary term. So the amplitude is 1. Now in this problem, x of n is given to be n minus 5 into u of n minus 5 minus u of n minus 6. Now we already know that u of n forms a DTFT pair with 1 by 1 minus e power minus j omega. So u of n minus 6 will form DTFT pair with, there is a shift. So if you have x of n minus n naught, the DTFT of which is e power minus j omega n naught into x of e power j omega, where n naught is a shift and x of e power j omega is Fourier transform of x of n. So shift is e power minus j omega into 6 into Fourier transform of u of n. It is 1 by 1 minus e power minus j omega. So the DTFT of u of n minus 6 is directly known. That means I can directly write it here. But now the challenge is to find the DTFT of n minus 5 into u of n minus 5. Now n minus 5 into u of n minus 5 will be, see there is a shift everywhere which is including n. So this will form DTFT pair with e power minus j omega into 5 into x of e power j omega, where what is x of j omega? X of e power j omega, it is the Fourier transform of x of n, where x of n, so here x of e power j omega is DTFT of x of n. X of n is what? N into x of n, n into u of n. Since you have shift everywhere, the shifting factor because of time shift property is this, that is e power minus j omega 5. Now we need to find DTFT of n into u of n. Now you have DTFT of u of n as 1 by 1 minus e power minus j omega, which I have already written here. Now n into u of n, the DTFT is, you have the property for frequency differentiation as minus jn x of n forms DTFT with d by d omega of x of e power j omega. So if I multiply minus jn x of n is u of n, its DTFT is d by d omega of 1 by 1 minus e power minus j omega. Why? Because d by d omega of x of e power j omega. What is x of e power j omega? It is Fourier transform of u of n. Now, but what I want is, I need to find n into DTFT of n into u of n. So I will be dividing here by minus 1 by j into d by d omega of 1 by 1 minus e power minus j omega. So this is DTFT. Now this will be minus 1 by j into d by d omega, that is differentiation of this term with respect to omega is 1 by 1 minus e power minus j omega whole square. It is of the form 1 by x, so minus 1 by x square is the differentiation into differentiation of the differentiation of the term which is considered to be x, that is 1, differentiation is 0, into differentiation of e power minus j omega with respect to omega is minus e power minus j omega into minus j. So this is the factor which I will be getting here when you differentiate 1 by 1 minus e power minus j omega with respect to omega. So that will be, this j gets cancelled with this j. I have minus, minus, minus and minus. So 4 minus signs, I will be getting a positive sign. So what I will be getting here is e power minus j omega divided by 1 minus e power minus j omega whole square. This is the DTFT of n into u of n. So I have got the x of e power j omega, that is Fourier transform of x of n, which is nothing but n into u of n. So this is the Fourier transform of n into u of n. You have shifted version, so you substitute x of e power j omega as this. So finally x of e power j omega is e power minus j omega into 5 into x of j omega, that is e power minus j omega divided by 1 minus e power minus j omega whole square minus u of n minus 6. What is u of n minus 6? E power minus j omega 6 divided by 1 minus e power minus j omega. So that will be e power minus 6j omega divided by 1 minus e power minus j omega whole square minus e power minus j 6 omega divided by 1 minus e power minus j omega. So this is the DTFT of the given signal.